Hi, my name is Tanishka Mehta, and for my experiment, I tested the strength and degradation of bioplastics. The purpose of this experiment is to see which biodegradable plastic degrades the fastest and which one has the most strength. The researcher became interested in this project when she found out that different polymers can affect the rate of degradation of biodegradable plastic, and it also affects the strength it has. The information gained from this experiment will show which biodegradable is the fastest to degrade and how much time it takes. It will also show which one is the strongest. Background research. Plastic plays an important role in our daily lives. On average, Americans collectively use over 2 million plastic bottles every hour, but few of these bottles are recycled or reused. The global annual usage of plastic exceeded 3 million tons, and nearly half was used to make single use plastics, which are designed to, to be used for a short time before being thrown away. Plastic comes from petrochemical plastic. This type of plastic is created through a chemical process with fossil fuels to make polymers. These plastic polymers take a long time to break down, potentially 1,000 years in a landfill. Researchers have recently discovered that there are now microplastics in our water supplies and even in our fruits and vegetables. In our oceans, they can break down very quickly, releasing toxic chemicals such as BPA. Bioplastics, also known as bio-based plastics, are plastics that aren't made from the usual earth-polluting materials like petroleum. Hypothesis: when the banana peel is placed in soil, it will degrade faster than a paper straw, wood, or conventional plastic spoon because banana peel contains natural polymers including starch and cellulose, which will degrade faster, while plastic spoon will not degrade and retain its strength. My second experiment is to prove that paper straw compared to banana peel, wood, and plastic spoon with the ability of forming hydrogen bond between fibers will be affected, which will lead to the decrease of interfiber bonding strength to show less compressive strength when it is placed in boiling water because heat breaks down the banana skin fiber. Variables. The independent variable are the bioplastics, which is the banana peel, paper straw, and wood. The dependent variable is the soil and the environment in the pots were placed, and the controlled variable is the amount of time, the ratio of the soil, and the amount of boiling water. The materials in this experiment is 1 jar soil, banana peels, plastic spoons, wood, paper straws, water, boiling pots, 20 plant pots, strainer, and weighing scale. How I performed my experiment. To test the degradation, I put each bioplastic into the soil and measured its molecular weight and mass and observed its physical properties every week. I would record how much each item degraded on a scale from 1 to 10, 10 being it has degraded fully. There were 5 trials, and all of the bioplastics would stay outside with full sun exposure. To test the strength, the exact procedure as degradation testing was performed, but I added boiling water every day to the soil and observed it weekly. The pots with biodegradable plastic and conventional plastics were placed in full sun exposure. The observation took place by placing 5 grams of weight after being a week of boiling water poured into the soil. There were 5 trials and it was rated on a scale from 1 to 10, 10 being it has the most strength. Conclusion: my hypothesis was proven correct that banana peel will degrade faster than wood or paper, and plastic will show no changes. In my 5 trials, 4 of the trials showed that banana peel degraded the fastest. It had mass, weight, and physical property changes. On trial 2, the paper straw degraded the fastest, showing a physical property change, and the banana peel took an additional 2 days more. This was shown for only 1 trial. For every trial, the wood did not show any physical or mass weight change. On average, banana peel showed the most amount of physical property and mass weight change. The plastic spoon did not show any physical or mass weight change. For the second part of my experiment to test the strength of the bioplastic, paper straws showed the least amount of compressive strength in all the trials. Banana peel loosened up its texture, making the banana peel's compressive strength stronger than the paper straw, but weaker than the wood and plastic. Plastic and wood showed the maximum compressive strength. This proved my hypothesis correct as paper straws compressive strength was the least showed maximum deformation. Future research. All plastic is degradable, even traditional plastic. Biodegradable plastic can be broken down completely into the water, carbon dioxide, and compost by microorganisms under the right conditions. Biodegradable implies that the decomposition happens in weeks to months. As I was researching more about bioplastic, I came across an article from the University of Pittsburgh 2010 study on bioplastic. According to the article, bioplastics are generally considered to be the more eco-friendly than traditional plastics, but this wasn't necessarily true when the material's life cycles were taken into consideration. The researchers determined that bioplastic production resulted in greater amounts of pollutants due to the fertilizers and pesticide used in growing the crops and the chemical processing needed to turn the organic material into plastic. The bioplastics also contribute more to the ozone than the traditional plastics and required extensive land use. So my future research would be how is bioplastic affecting our environment and how it's living up to its hype.